questions 21 to 25 on the 2002 Grade 7 Gauss Math Contest. 5 people are in a room for a meeting. When the meeting ends, each person shakes hands with each of the other people in the room exactly once. The total number of handshakes that occurs is. So let those 5 people be represented by A, B, C, D, and E. So A will first shake hands with B, then we'll shake hands with C, then with D, and then with E. And each person shakes hands with each other person exactly once, so there's no repeats. So then B will shake hands with C, then with D, and then with E. And then finally C will shake hands with D, and then with E. And then at the very end, D will shake hands with E. So we got 4 handshakes here, 3, 2, and 1. 4 plus 3 plus 2 plus 1 is equal to 10. Total of 10 handshakes. 21, the answer is B. The figure shown can be folded along the lines to form a rectangular prism. The surface area of the rectangular prism is. So let's see here. This is 6, 6, 6, and 6. This is 10, 10, 10, 10, 10. And if it's being folded up to become a box, this is going to be 5 and 5. And this has to be 10, and that has to be 10. So the surface area is what they want, not the volume. So don't make that mistake. So surface area, let's just do the surface area side by side. So this first one here, we've got surface area, the area rather, is 10 times 6, which is 60. And then the next one over is 5 times 6, which is 30. This one here, these sides are 5, 5, 5, and 5 like that. So this box, 5 times 10 is 50. In the middle, 6 times 10 is 60. And this is 50. And this is 5 times 6, which is 30. So those are the areas. And then to get the full, you just have to add them up. So it looks like we've got 60 plus 60, we have 50 plus 50, and then we've got 30 plus 30 like that. And that looks like 120 plus 100 is 220 plus 60, so 280. So number 22, the answer is C. Mark has a bag that contains 3 black marbles, 6 gold marbles, 2 purple marbles, and 6 red marbles. Mark adds a number of white marbles to the bag and tells Susan that if she now draws a marble at random from the bag, the probability of it being black or gold is 3/7. The number of white marbles that Mark adds to the bag is. So he's got 3 black, 6 gold, 2 purple, 6 red. And he then adds a certain number of white marbles, right? We don't know the number. And then he says, now the probability, based on everything I have here, of getting black or gold is 3/7. So if we use our values, black or gold, so we want either 3 black or 6 gold. That's the probability of getting that or the other. And then you divide by the total, which is 3 plus 6 plus 2 plus 6 plus white. We don't know how many white. That's what we're actually trying to figure out. So 3/7 equals 9/9 plus 8, which is 17. Cross multiply and you get 63 for 7 times 9, and then 3 times 17, 51 plus 3W. So 63 minus 51 is 12, equals 3W, and therefore W is 4. So he added 4 white marbles to the bag. So number 23, the answer is D. PQRS is a square with side length 8. X is the midpoint of side PQ, and Y and Z are the midpoints of XS and XR, respectively, as shown. The area of the trapezoid YZRS is. Let's start labeling this. It's a square of side length 8, so the whole side there is 8. And we know that these two lines mean that those are equal. So that means if X is the midpoint, those are 4 and 4. And very similarly, we can find all the other sides. For example, if we draw a perpendicular from Y down to the bottom, and then we do the same with Z, and then we draw, let's say, lines all the way across, we can get some additional values. Y is the midpoint of XS, so they actually have given us that by telling us those sides are the same because of those lines. Now, because of the symmetry of this diagram, if you were to draw a line all the way from X down to the bottom like this, right? That line is equal to 8. It's the same as this guy right here. But when you draw a line from Y to Z, it basically cuts that in half. So that means that this distance right here is 4. And similarly, when you drop a perpendicular all the way to the bottom like that, this will cut SR in half like that. So that means this is 4 and that is 4. And then you have drawn a line from Y down to the bottom like this. And that, of course, will be 4, and so is this. So I hope that makes sense. And then finally, this line here, when it drops down to the bottom, it cuts that in half. So therefore that becomes 2, that's 2, that's 2, that's 2, and this is 2, and this is 2. So we've labeled it all, and now we can calculate the area. The area of the trapezoid, so YZRS, YZRS. Now, if you don't know how to calculate the area of a trapezoid, that's perfectly fine. We can just do it by subtracting. So we have the total area, which is the square. Okay? Then we subtract from it this triangle right here. Okay? So I'll put that in there, that triangle. Then we subtract from it that triangle. So like this. And then finally subtract from that triangle, that small one in there. And that will give you the area that we're looking for. So let's do this. The area of the square is 8 times 8 minus 1/2 base times height, which is 4 times 8, minus another 4 times 8, 1/2. And then finally minus the little guy, which is 1/2 base, which is 4, times height, which is 4. So this is 64. 4 times 8 is 32, so that's 16, minus 16, minus 4 times 4 is 16, divided by 2 is 8. So we've got 64 minus 32 minus 8, 64 minus 40, and this is 24. So the answer is A. I just wanted to mention the area of a trapezoid is basically, if you have a trapezoid like this, and this is A, and this is B, and this is the height, the area is A plus B over 2 times the height. So we can use that to figure this out. So for example, A in this case is from here to here, which is 4. B is down here, which is 8, all over 2, and times the height. The height is right there, 4. So this would be 4 plus 8 is 12. 12 over 2 times 4. And this is 6 times 4, which is 24. So we get the same answer. So the answer is indeed A for number 24. Each of the integers 226 and 318 have the digits whose product is 24. How many 3-digit positive integers have digits whose product is 24? So we've got a 3-digit number, say A, B, and C. And if you take the individual digits and multiply them by each other, they will equal 24. And they want you to figure out how many such numbers are there. Well, 24, that number itself, we want to break it down to its prime factors. So it's 2 times 2 times 2 times 3. So its prime factors are 1. 1 goes into it, of course. But 1 is not a prime factor, but it is a factor. 2, 3, 4, 6, 8, 12, and 24. These are the numbers that divide into 24. But we only are interested in the single digits, because that's how we're going to make this number. We can't put a 12 or a 24 in there because those are obviously double digits. So our numbers are going to consist of some of these numbers. We don't know yet, but the criteria is that those three numbers, when multiplied together, have to equal 24. So let's start making a list here. So if I choose 1, let's start with 1. Can I choose 2 as the next digit? If I did, 1 times 2 times something would have to equal 24, and that something would be 12. And that's obviously not going to make a 3-digit number. So I can't choose 2, but I can choose 3, because 1 times 3 times some number equals 24, and that some number is 8. So there you go. I've got my first number of all the numbers I need to find. So let's keep going here. 183 would also work, right? I just reversed the order a little bit. And I will stay with these numbers and just try to find more combinations of them. I will stay with 1, 3, and 8. So 3, 1, 8, 3, 8, 1, 8, 1, 3, and 8, 3, 1. All right, so all of these have this property that when you multiply the digits together, it equals 24. So now let's move on. We've exhausted all the ones. Or have we? Aha. Let's keep with 1 then. If we haven't exhausted it, let's keep with 1. I can't choose 2. I've already explained why. I've already done the 3, so now let's go with the 4. 1 times 4 times some number is 24, so that number has to be 6. Okay? So now these 3 digits, I will try to make more numbers out of. 164, 416, 461, 614, and 641. All right, all of these have that property that when you multiply the digits together, it equals 24. Okay, let's move on. Can we go with 1 again? 1, 6. If I move to the next one, therefore this would have to be 4. 1, 6, 4. But I've already done that. See, I've already exhausted this. So this one would be essentially a repeat. So that's no good. How about 1 and 8? And therefore this would have to be 3. But I've already done that over here. So I have indeed now finally exhausted the ones. So let's move on. Let's move on to 2. Just 2 by itself. Then if I put the next digit as 1, that's not going to work, right? Because then this would have to be a 12. So that's no good. How about if I put the next digit as a 3? 2 times 3 is 6. And then 6 times what is equal to 24? 4. So there you go. That's another combination. And then with these 3 numbers, I will create more numbers. So 2, 4, 3, 3, 2, 4, 3, 4, 2, 4, 2, 3, and 4, 3, 2. All right, so I hope you're following that. So let's see. I did 2, I did 3, I did 4. What's next? If I have 2, stay with the 2, I guess, and let's put the next one over, which is 6. If I have 2 and 6, that 2 times 6 is equal to 12. So 12 times something has to equal 24, and that's 2. Nothing in the question says that I'm not allowed to use the same number twice. So 262 meets that criteria. Now, can I get more combinations? 226 and 622. That would mean just a little bit of a order reversal. And at this point, let's see if I can keep going. 8. 2 times 8 is 16, but 16 times nothing is 24, so that's no good. And then if you keep going like this, you'll find that we have pretty much exhausted all the combinations, because if you start with 3 and then you keep going, you'll either find that there's no way you can do it, or you will keep coming back to the ones that we just did. So I encourage you to sit down and work through this problem. So how many did we find here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 numbers that have that criteria where the digits, if multiplied, equal 24. So number 25, the answer is E.